There are about 125 types of engines produced worldwide, but all of them pale in comparison next to SpaceX's latest advanced rocket engine, the Raptor engine. But more importantly, a variant of this super powerful engine called the Raptor Vacuum has somehow become an almost unimaginable engineering marvel. Let's explore this engine in SpaceX's latest test on today's edition of Alpha Tech. So, over the past weekend, we all saw this explosive static fire test of Ship 30. However, what was even cooler was that thanks to the new test infrastructure, for the first time, close up videos underneath the engines were released with such authenticity. 6 engines were ignited in sequence, starting with the 3 outer vacuum engines, followed by the 3 inner sea level Raptor engines. But what we're most interested in is likely the operation of Raptor's vacuum. The reason for this is the Raptor vacuum engines are different from the sea level engines. While sea level engines are designed to operate efficiently at sea level and can be accurately tested on the ground, Raptor vacuums are designed for use in the vacuum of space. These engines will play a crucial role in taking our Starship spacecraft to nearby planets in space without any problems. To visualize this more clearly, we can also mention the test of reigniting the Raptor engines in space that SpaceX has skipped twice for Starship. This test could help the company determine whether the space engines can restart in the extremely cold conditions caused by extended time in space. Of course, they've successfully conducted similar tests with Raptor Vacuum in simulated vacuum environments at their test facilities, but it certainly wouldn't be as valuable as doing it in reality. With Starship's upcoming 5th launch, I believe that in addition to catching Super Heavy with the launch tower, SpaceX will also perform the task of reigniting the engines in space. With a separate video of the Raptor vacuum engine test posted by SpaceX in early April, we have a more stunning view of the beauty and power of this beast of an engine. In the video, the engine's in the process of shutting down with a magnificent blue exhaust plume, and we can see vortices forming and moving inside the nozzle as the engines throttle down. These vortices occur due to a phenomenon known as flow separation. Flow separation happens when atmospheric pressure compresses the exhaust gases as they exit the engine nozzle. As the engine throttles down, the exhaust pressure decreases and the surrounding air begins to take over, pressing into the nozzle and creating oscillations and vortices in the exhaust flow. To prevent these oscillations from damaging the engine during testing at sea level, Raptor's vacuum engine is always equipped with a support ring near the end of its large nozzle extension. It's incredible to witness how much happens in such a short time when the engine is running, or rather, when it's shutting down, as in this case. The entire shutdown process takes just over a second, but who would have thought that something as simple as shutting down an engine could be this fascinating? So drop us a heart in the comment if you're liking this video, and please like and subscribe to our channel. All right, not only that, the attraction also lies in the sheer size and inherent power of this engine. Have a look at this previously released photo of SpaceX. Raptor Vacuum is gargantuan. The enhanced size is primarily attributed to the significant expansion of the engine's nozzle. The wide nozzle of the Raptor Vac engine results in an area ratio of 200, necessitating a nozzle diameter of approximately 4 meters. This enlargement of the nozzle positively impacts operational efficiency in the vacuum of space. Due to its characteristics in a vacuum environment, Raptor vacuum engine boasts an impressive thrust of 357 tons, with a specific impulse hitting a remarkable 380s. This specific impulse measurement surpasses that of many renowned rocket engines, including the vacuum version of the BE-4, and that has a specific impulse of 339s. The RD-180 has got an impulse of 338s in a vacuum, and even the legendary RS-25 space shuttle engine with a specific impulse of 452s, but featuring 2 combustion chambers. But why do we compare specific impulses between these vacuum engines? Specific impulse means how efficiently a rocket expels its propellant. It quantifies the rate of thrust generated by expelling propellant from the nozzle and is measured in seconds. A higher specific impulse implies a greater expulsion velocity of the propellant. This metric serves as a measure of engine quality, essentially reflecting how quickly the engine burns fuel to propel the rocket upwards. This is the most crucial key performance indicator of a rocket engine, as a faster and more efficient burn rate can accelerate the rocket to higher altitudes and velocities with less fuel consumption. Additionally, the specific impulse for vacuum engines always exceeds that of sea-level engines. In a vacuum, there is no atmosphere to provide pushback against the expelled gas, unlike at sea level, where the ambient atmosphere contributes to thrust. For instance, SpaceX's current Falcon 9 launches employ the Merlin engine, which exhibits a specific impulse of 282s at sea level and approximately 311 in a vacuum environment. Therefore, it's only natural for the Raptor vacuum to possess greater power compared to its sea level counterparts. Honestly, the future iterations of the Raptor vacuum engine are likely to be even more potent, possibly up to 400s. So impressive a figure among all rocket engine lines. That's because SpaceX's engine development is progressing at an amazing rate, exemplified by Raptor 3, which boasts a staggering 17% increase in power compared to Raptor 2. I cannot wait to witness this. It's going to be awesome. Not only outperforming other rockets, but Raptor vacuum engine is also a huge milestone in SpaceX's pursuit of advanced propulsion technology. This innovative vacuum engine variant builds upon the foundation of its predecessors, incorporating distinctive features that cater to the demands of space travel. At the heart of the RapVac prototype is its ingenious regenerative cooling system. Unlike conventional cooling methods, regenerative cooling involves circulating propellant such as methane through the walls of the engine's nozzle and combustion chamber. This process effectively absorbs the extreme heat generated during combustion, preventing overheating and structural damage. The regenerative cooling system enhances the engine's endurance and longevity, enabling it to withstand the rigorous conditions of space travel. The manufacturing process of RapVac's nozzle is quite remarkable. Crafting regeneratively cooled nozzles traditionally involved labor-intensive methods, like assembling thousands of individual pipes. However, the RapVac engine takes a novel approach. This nozzle is meticulously crafted from a copper sheet. Copper sheet is then enveloped by Inconel sheets, creating a sturdy and efficient channel wall. This manufacturing technique streamlines the production process and contributes to the engine's overall efficiency. In its pursuit of optimal performance and durability, RapVac engine boasts additional reinforcements and protective elements. These components are strategically incorporated to enhance the engine's structural integrity and mitigate potential challenges. Notably, the interior of the engine features a white ceramic material believed to reflect heat and safeguard the chamber wall against oxidation. Additionally, the design of vacuum engines is also given careful consideration to maximize efficiency. The first factor that needs attention is the expansion ratio, which holds paramount importance in vacuum engines. This ratio, which represents the ratio of the cross-sectional area of the engine's exhaust nozzle at the throat to the area at the exit, plays a pivotal role in determining the engine's overall performance. A higher expansion ratio leads to enhanced efficiency by enabling the engine to extract more energy from the expanding exhaust gases as they propel the spacecraft forward. However, as engines venture into the realm of larger nozzles, a complex challenge arises in the flow separation phenomenon. Flow separation occurs when the pressure of the exhaust gases drops significantly, leading to the atmosphere exerting pressure back into the nozzle. This phenomenon can result in adverse effects on engine stability and thrust efficiency. Large nozzles are particularly susceptible to flow separation due to the decreased pressure of the exhaust gases in the vacuum of space. This is a video that shows the main engine of the space shuttle running at full power. Before hitting max thrust, you can see the exhaust flow spreading around the nozzle's tip, then gradually increasing, similar to an accelerating vehicle. Additionally, you can observe the nozzle oscillating more as this phenomenon becomes more pronounced towards the rear. This phenomenon generates significant lateral forces, which, if sustained, could potentially damage the engine. Yikes. Addressing the challenges posed by flow separation in large nozzles is vital for optimizing engine efficiency and stability. Engineers must carefully balance expansion ratios and nozzle sizes to mitigate the adverse effects of flow separation. Through meticulous design and advanced simulations, they strive to achieve a harmonious flow of exhaust gases that maximizes thrust while minimizing flow separation. Besides, the quest for an optimized RapVac engine also entails adjustments beyond the nozzle. The engine's power head, the heart of its intricate machinery, might need re-engineering to accommodate changes in flow rates and pressure. Furthermore, the intricate dance between propellant pump config demands meticulous synchronization to ensure optimal thrust production without compromising combustion efficiency. These changes, while challenging, could unlock the engine's full potential and set new benchmarks for space propulsion. In general, SpaceX's Raptor Vacuum is a mysterious beast in space, and as Elon keeps on tweaking and upgrading those Raptors, Raptor Vacuum will also benefit from his genius solution. This opens up many possibilities for SpaceX and the future of space exploration. NASA signed a $2.89 billion contract with SpaceX to develop the human landing system for Artemis 3 that's expected to take astronauts to the moon in 2026. Plus, there is a separate $1.15 billion contract signed last year for Artemis 4, and that's projected to happen in 2029. Raptor engine in general and the Raptor vacuum engine in particular will play a huge role in powering Starship during its ascent and descent from the lunar surface. Looking beyond the moon, SpaceX has its sights set on Mars. The company's long-term vision is to establish a self-sustaining city on the red planet, and Raptor engine's the main driver behind this ambitious goal. The engine's ability to use methane as fuel, which can be produced from Martian resources, especially makes it suitable for extended missions and in-situation resource utilizations. Beyond crewed missions, the Starship and Super Heavy vehicles powered by Raptors also have the potential to revolutionize the launch industry. The fully reusable design and rapid turnaround capability of the system could significantly cut the cost of access to space, making it more affordable for a wide range of payload, including satellites, space telescopes, and interplanetary probes. SpaceX is also exploring the possibility of using Starship for point-to-point transportation on Earth. By leveraging the vehicle's ability to perform suborbital flights, the company envisions a future where passengers could travel between distant cities in just a matter of minutes. Yes, please. While this application is still in the conceptual stage, the performance and reliability of the Raptor engine will be key to turning this vision into a reality. Engines are the key factor for the sustainable growth of an aerospace company, and SpaceX is leading in this area. However, ULA, an organization unable to achieve similar advancements, has been criticizing SpaceX's technology. So in response to this, SpaceX leadership has delivered some sharp rebuttals, leaving ULA embarrassed. Just last week, we got our first glimpse of the new Raptor 3 engine, and notably just a few days later, SpaceX did its first test firing. On August 8th, at SpaceX's familiar engine testing facility in McGregor, the exciting test of the Raptor 3 took place. Imagine, the appearance of the Raptor 3 alone leaves us in awe. Its impressive streamlined design combined with superior technical specs sets a standard that few rocket engines can reach, and that's only the beginning. When Raptor 3 truly roars during its first test, we're bound to witness a performance that exceeds all expectations, revealing the true potential of this groundbreaking machine. Although SpaceX has not yet released a video of the Raptor 3 engine test, Elon and Gwynne Shotwell have shared the latest images of this commendable effort. These images demonstrate the full combustion operation of the Raptor 3 engine, and it looks awesome. The clear blue exhaust plume characteristic of a methane-rich engine also indicates an efficient fuel mixture combustion ratio while being able to generate more thrust from the same amount of fuel. One thing I noticed, that this is a significant improvement over previous generations of Raptor engines like 1 and 2, whose exhaust still produced quite a bit of carbon, as evidenced by the exhaust having more red or yellow colors. But did you see the white part on the engine body? Well, it's not exactly white as our eyes perceive it. Elon explained right below the images, the parts that appear white are actually black but covered in ice. Indeed, those pristine white patches are created from the extreme temperature difference in the rocket engine. It originates from the basic principles of thermodynamics and chemistry. Rocket propulsion relies on a controlled chemical reaction that releases an enormous amount of energy. To achieve this, we need to store large quantities of fuel and oxidizer in a compact, efficient manner. Liquefying gases like methane and oxygen allow us to store much more of them in a smaller volume compared to their gaseous state. However, these substances only become liquid at extremely low temperatures. That's why storage tanks and pipes are just so cold. They must maintain these cryogenic temperatures to keep the propellants in their dense liquid form. The fuel, methane, and oxidizer, oxygen, are stored as very cold liquids. Liquid methane has a temperature of about minus 160 degrees Celsius, while liquid oxygen even colder at about minus 180 degrees Celsius. That's cold. When these super cold liquids flow through the pipes, they cool the metal to well below the freezing point of water. The moisture in the air around these pipes instantly freezes upon contact, and that creates the frost we see. This process, called condensation and deposition, is the same principle that causes frost on your car windows on a cold morning. The Raptor engines used in modern rockets pumps about 650 kilos of these cold liquids every second. The mixture is roughly 1 part methane to 4 parts oxygen. When these cold liquids mix and ignite in the engine, they create extremely high temperatures, hot enough to incinerate materials almost instantly. This dramatic shift from ultra cold to super hot is what makes rocket propulsion possible. The frost you see is not intentionally designed. It's a natural consequence of the extreme cold meeting normal air temperature and humidity. Many people in the space community have been highly supportive, even praising Elon and the advanced Raptor 3 engine. However, not everyone's pleased with this. There's just a little bit of envy and jealousy in there. Yeah, none other than one of Elon's major rivals, Tory Bruno, the CEO of ULA. Bruno has expressed skepticism about the Raptor V3 engine right from the get-go when Elon put the first picture of Raptor 3, saying that the images showed an incomplete assembly, stating they have done an excellent job making the assembly simpler and more producible, Bruno shared on his X account. So there's no need to exaggerate this by showing a partially assembled engine without controllers, fluid management, or TV systems, then comparing it to fully assembled engines that do. Gwynne Shotwell, SpaceX's president, ironically responded to Bruno's skepticism by sharing a photo of the first test firing of Raptor 3. Works pretty good for a partially assembled engine. The images showed that the engine is indeed complete and does not require any additional parts to function. So why would Tory Bruno do this? Is he jealous of SpaceX's dominance? Let's get into this. SpaceX's dominance in the space industry has become increasingly evident as demonstrated by the latest data from the first quarter of this year. The company's achievements during this period underscore its growing lead over competitors and its potential to reshape the entire space industry. In the first 3 months of the year, SpaceX did an impressive 31 launches, far outpacing its closest rivals. This figure is more than triple the launches of Chinese Aerospace Science and Technology Corporation, CASC, which did 9, and over 6 times Russia's Roscosmos that did 5. This disparity highlights SpaceX's superior launch capabilities and operational efficiency. The contrast becomes even clearer when considering the number of spacecraft deployed. SpaceX launched a staggering 525 spacecraft in the quarter, primarily driven by its Starlink satellite constellation project. In comparison, CASC did 27 spacecraft, while ULA, a joint venture between Lockheed Martin and Boeing, only launched 7. This vast difference underscores SpaceX's ability to not only launch more frequently, but also to deliver much larger payloads per launch. Looking ahead now, SpaceX's ambitions for the rest of the year are nothing short of revolutionary. The company aims to complete 144 launches throughout the year, averaging about 3 a week. This unprecedented frequency would mark a new era in space accessibility and utilization. Elon's statement that SpaceX might exceed 90% of all Earth payload to orbit later this year further emphasizes the company's potential to completely dominate the global launch market. This level of market control could have far-reaching implications for the space industry. It could force competitors to innovate rapidly or risk going into obscurity, potentially leading to a restructuring of the global space sector. Tory is likely quite a bit worried about SpaceX's rapid development and frankly unhappy with how the company's impacting the whole space community. That's why ULA has joined forces with Blue Origin in a lawsuit against SpaceX. But in any case, I think SpaceX is going to respond to them with well-deserved accomplishments. With Tory Bruno's latest dismissive remarks, Musk just responds with a short LOL. In a later post, the CEO explained that all the small plumbing and wiring involved in the engine had to be either removed or integrated into the primary structure in the engine, as it would have no heat shield. Also, all parts have to be actively cooled in some way, so we added regenerative cooling where there's no existing fluid or gas flow, Musk added. Indeed, the regenerative cooling method involves circulating cryogenic methane outside the main combustion chamber so it keeps cool. The warmed liquid methane then flows into the preburner to continue the cycle, and because of this, it no longer requires an additional heat shield like previous engine versions. And that's not all. Among other features, Raptor 3 eliminates small pipes and wires, incorporating some of them into its main structure. It also merges many components into single complex pieces using 3D metal printing on the engine walls. By removing, integrating, or simplifying components, Raptor 3 weighs half as much as Raptor 1, including the mass of the engine and the hardware made by the rocket. The total weight of Raptor 1 is 8,000 pounds, Raptor 2 6,430 pounds, Raptor 3 cuts the total weight to 3,790 pounds, with 3,362 pounds from the engine and 428 pounds from induced mass. Considering Super Heavy, Starship's first stage, has 33 Raptor engines, with SpaceX planning to add 2 more, the weight savings between the current and next generation of engines is 40 tons. This meticulous simplification process reduces the weight of the engine and increases its rapid reusability. On top of that, it enhances SpaceX's ability to mass-produce Raptors. The no part is the best part manufacturing approach lessens the need for assembly, improves structural integrity, and reduces material waste, resulting in more efficient and sustainable manufacturing processes. This will be crucial in the future when Elon plans to cut the turnaround time between Starship flights, potentially to 1 Starship per week or even 1 a day. Honestly, the Raptor is the ultimate all-purpose engine, and according to SpaceX, Raptor 3 can generate a downward thrust of 280 tons. It might not be the most powerful rocket engine ever, but it holds the crown among all active rockets and is by no means lacking in any way. Reusability is a major consideration in the design of Raptor. SpaceX aims to reuse each engine 1,000 times. Since most other rocket engines have very limited or no reusability, the cost per flight for Raptor is going to be relatively low. This will make space travel more affordable and accessible in the future. SpaceX has set some ambitious cost targets for the Raptor engine, aiming for making them at a cost of less than $1,000 a ton of thrust, equating to approximately $250,000 an engine. Achieving this goal would enable cost-effective production, facilitating the scalability of space exploration endeavors. In 2022, SpaceX announced its capability to make 1 Raptor engine a day at its McGregor facility in Texas, demonstrating significant progress in meeting those production targets. A key feature distinguishing the Raptor engine is its utilization of liquid methane, CH4, and liquid oxygen, LOX, as fuel sources, a combination known as methalox. This choice of fuel holds importance for space exploration, particularly for missions to Mars, as both methane and oxygen can be potentially generated from Martian resources and in situ resource utilization, ISRU. ISRU is vital for establishing a sustainable human presence on Mars, as it enables the production of propellant using locally sourced materials, reducing reliance on Earth-based supplies. Furthermore, the use of methane as a fuel offers environmental benefits as it burns cleaner than traditional rocket fuels such as RP-1 kerosene, resulting in fewer pollutants. The Raptor engine's exceptional power is instrumental in facilitating human travel to Mars, enabling spacecraft to achieve unprecedented speeds of efficiency, thereby advancing the feasibility of interplanetary exploration and colonization. The Raptor engine's development underscores SpaceX's commitment to advancing reusable rocket engine technology with a focus on maximizing reliability in even the most challenging of environments. Through rigorous testing and continuous refinement, SpaceX aims to ensure that the Raptor engine becomes a cornerstone of reliable propulsion for future space missions. Beyond its technical prowess, the Raptor engine plays a pivotal role in SpaceX's broader vision of revolutionizing space travel. By driving down costs and increasing accessibility to space, SpaceX seeks to pave the way for ambitious endeavors like establishing a long-term lunar base and creating the first self-sustaining colony on Mars. This vision aligns with Elon's ambitious timeline, which includes sending an unmanned Starship to Mars after NASA's Artemis mission to the Moon, potentially by the mid-2020s. Elon envisions the possibility of establishing the first human settlement on Mars by 2050. As SpaceX continues to refine and integrate Raptor engine into its spacecraft, we can anticipate further strides in exploration and travel. These developments hold the promise of unlocking new frontiers in human exploration, ultimately shaping the future of interplanetary civilization. Are you ready? The 5th flight of Starship has just been given a new launch date, and Elon Musk has revealed this, and there's no reason for us not to believe it. So when will that 5th Starship flight be happening? Are there any challenges for SpaceX in the upcoming missions? Recently, SpaceX provided the latest updates on Starship after a considerable period of silence. On the weekend of August 8th, the company shared on the X platform that Flight 5 Starship and Super Heavy are ready to fly pending regulatory approval. And while waiting for the regulatory body to evaluate the extremely complex Catch Tower plan, SpaceX plans to conduct additional recovery tests and continue developing the vehicle for Flight 6. This seems to be a positive signal for everything that's about to happen. As expected, not long after, Elon Musk reaffirmed the launch date for the Starship flight as about 3 weeks on August 11th on his X platform. This means the next Starship test flight could get FAA approval by the end of August or early next month, potentially happening on August 29th, 30th, 31st, and September 1st. So what day is that going to happen? Don't hesitate to let us know your predictions down there in the comments. Although this timeline is somewhat delayed compared to earlier statements about a launch last month, the inherent risks of the Catch Tower operation seem to have extended the FAA's scrutiny after the agency previously indicated they could expedite Starship approval if SpaceX decides to proceed with both launch and recovery ops along with the flight path. Don't be too disheartened by that delay. In any case, fifth Starship flight's going to be a performance you won't want to miss. This will be the first flight where SpaceX attempts to catch Super Heavy before the successful soft landing and intact recovery of Starship, as seen in the fourth launch that happened in June. If successful in the sixth flight, SpaceX and Elon will certainly be aiming for even more ambitious feats with the spacecraft. We could even imagine a near future where Mechazilla can complete 2 catches with both stages of Starship. However, there are also risks, such as the possibility of Super Heavy malfunctioning and endangering the only operational Starship launch tower. To complete this process, Starship needs to achieve precision in position, height, and timing. The stage has an onboard navigation system using gyroscopes and accelerometers, which provide a really good dead reckoning position calculation. It also has radar, which is used to give an indication of height and possibly horizontal angle and speed during the final part of the landing. It may also use GPS as an additional position or reference. All of these together are combined by the onboard computers to give a good indication of where the rocket is in relation to the target landing spot. Raptor engine can be accurately throttled over a wide range, and SpaceX has enough experience with them to accurately predict how much thrust the engine will give at different throttle settings. The actuators that steer the engine are pretty strong and can shift the engine from side to side quickly. On top of that, the descending stage has cold gas thrusters and 4 electrically controlled grid fins used for steering during descent. The stage's onboard computers know where the rocket is and where it needs to be, and they know how the engine will respond to throttling and steering, how strong the thrusters are, and how well the grid fins will work at different speeds and heights. Solving the problem of how to get to the landing site from the current position using the various control methods available is a pretty hard mathematical problem, but computers fortunately are very good at math. Besides the Catch Tower, another important test that SpaceX may conduct during Starship Flight 5 is the reignition of the engines in space. This test was skipped during the third and fourth test launches, and right now, it's not hard to guess that it'll be happening during Starship's fifth flight. This is a big-time test for the future when SpaceX and Elon aim for Starship to play a central role in their ambitions for Mars and even multiplanetary missions. Long-distance travel anywhere in a vacuum environment will no longer be an obstacle for this ginormous spacecraft. However, restarting engines in the vacuum of space with extremely cold temps is not easy. As a general rule, the more complex a rocket engine is, the harder it is to reignite, especially liquid-fueled rocket engines. They have to pump large amounts of liquid fuels up to very high pressure before they enter the combustion chamber and be lit up to start the engine, and this requires an enormous amount of power to achieve, thousands of horsepower for a large engine. The launch tower infrastructure can provide this power via high-pressure nitrogen gas lines that disconnect at initial launch, but after that, a rocket requires its own store of high-pressure gas to restart for a second time. There are 2 other complications to restarting. One, the rocket engines require a highly reliable source of ignition to start. This is typically provided by either injecting a hypergolic fluid, 2 chemicals that when mixed spontaneously catch fire, or a special kind of spark plug. And 2, the fuel needs to get to the pumps to restart the engines. This is easy for most engines because gravity is used to accumulate the fuel at the bottom of the tank. Rockets are often operated in zero gravity, and this method doesn't work. The liquid fuel droplets are floating freely inside the half-empty tank. Before attempting a relight, the rocket needs to be shoved forward to push all the liquid into accumulating at the base of the tanks where the pumps can grab it. If the pumps are spun up without the propellant there, the pumps will fly apart and destroy the engine. Difficulties are present, but I guess these scenarios won't be too much of an obstacle for SpaceX. After all, these are engineers with nearly a century of experience working with their Falcon rocket line. Let's trust and look forward to the miracles that'll happen in any way possible. While waiting for the FAA to grant permission for the flight, the pair of Ship 30 and Super Heavy Booster 12 are getting ready to face the upcoming goal. After Ship 30 was equipped with a new, stronger heat shield design and additional backup protection, it completed a static fire test with all 6 engines running at full capacity. However, after the test was completed, Ship 30 got moved to Mega Bay 2 to replace one of its engines. This has led to speculation that the spacecraft encountered some issues after the test. This is not new. Ship 30 had a similar issue after its first static test back in May. This shows the importance of static tests in identifying and addressing problems before the actual flight. Now, with a new engine replacement, the question arises, will SpaceX need to conduct another static test for Ship 30? The question comes up as Ship 30's movement schedule has been somewhat unpredictable. On August 9th, Ship 30 left Mega Bay 2 with predictions that it would move to the Massey for a static fire test. But in reality, Ship 30 moved to Rocket Garden, and as of the time I'm making this video, there's been no further movement from Ship 30. As for Booster 12, we also got a glimpse of the hot staging at the end of last month, but since then, no perfect design has appeared. They may still be fine-tuning it. But soon, the story will continue. Booster 12 and Ship 30 might complete a wet dress rehearsal afterward. It's unclear when or even if this is going to happen or how close to the launch it'll be. Besides prepping for the 5th flight, SpaceX has been developing hardware for its future Starship rockets. Now that work on Ship 30 is complete, let's talk about Ship 31. About a week ago, Ship 31 was taken out of Mega Bay 2 after 6 Raptor engines were installed and moved to High Bay. Typically, the next step would be engine testing, but it seems SpaceX has other plans for Ship 31. That's not too surprising, as Ships 30 and 31 are almost identical. When Ship 31 was put next to Ship 30 at High Bay, where Ship 30 was having its heat shield replaced, we got an idea of what was coming next. Workers began setting up scaffolding around Ship 31 and taking off the old heat shield, beginning with the ship's nose and fins. Looking back at the heat shield replacement process for Ship 30, SpaceX started the removal right after the 4th flight on June 11th and finished on July 20th. It took them over a month to completely replace the world's largest heat shield. With the experience gained, hopefully the heat shield replacement for Ship 31 will go faster, possibly even before the 5th flight. As for the other half of Ship 31, Booster 13 has been on the Central Work platform at Mega Bay 1 since it completed its cryo-proof test at the end of April. Teams are now working on erecting a tent over the forward dome of Booster 13, suggesting that some major work's being done on the booster. Also, Booster 13 still does not have grid fins. Not only that, SpaceX continues to prepare for Flight 6. One crucial step is returning B-14.1 to the orbital launch mount for testing. In late June, B-14.1 was attached to the OLM and underwent a procedure called chopstick slapping. This test aims to adjust the speed and control of the chopstick arms in preparation for the actual landing of a booster rocket in the future. Additionally, the engineering teams tested the landing rail system to ensure it could withstand the necessary sudden loads. Following initial tests, SpaceX made improvements. They replaced many connections on the landing rails on both arms while upgrading and adding more drive systems. These enhancements aim to increase the system's load-bearing capacity and improve its controllability. Another important change is the upgrade of the buffer pads used in the slapping of B-14.1 in June. For the northern arm, the entire drive system got replaced, while on the southern arm, only the main drive got upgraded. As a result, after these changes are completed, both arms will be capable of moving at max speed. And with these improvements, SpaceX plans to conduct a comprehensive hand slap test, where both arms simultaneously perform a rocket-catching simulation. Notably, this time they plan to execute a complete motion, including raising the arms after slapping, an important step that they didn't perform in the previous test round. When NASA was trying to resolve issues surrounding the Starliner spacecraft, it caused the Crew 9 mission to get delayed by a month. But that wasn't enough. The delay has even affected the schedule for SpaceX's first spacewalk. So what the heck is going on in the space industry these days? In the past, we were uncertain about the timeline for the first private spacewalk. The Polaris Dawn team has now officially launched the target launch date for this important mission, saying, "We are targeting no earlier than August 26th for the launch of Polaris Dawn." It's not just a coincidence that this announcement came right after the meeting between NASA and Boeing, where decisions were made regarding the fate of the Starliner and its 2 astronauts. While it is difficult to definitively say that the issues with Starliner are causing delays in other missions, that's exactly the reality. NASA's latest decision, August 7th, presents 2 main options to resolve the ongoing problems with the cursed Starliner spacecraft, the most viable option being to delay Dragon's launch for the Crew 9 mission. Initially planned for this month, the mission's now pushed back to late September to take on responsibility of bringing the 2 Starliner astronauts back to Earth. To achieve this, Crew 9 mission will only include 2 astronauts instead of 4, with Wilmore and Williams joining the augmentation crew on the space station and returning to Earth in February 2025. However, the interesting and somewhat ironic point about NASA and Boeing here is that the delay of Crew 9 is just a secondary measure to accommodate the testing and unreliability of Starliner's program. NASA and Boeing are continuing to sacrifice the time of 2 astronauts, keeping them on the station until at least mid-September to further investigate Starliner's issues. If NASA's engineers feel more comfy with the uncertainties regarding Starliner's thruster performance, the astronauts may return to Starliner. Looking back at all NASA's decisions, they remain stubbornly committed to Starliner, imagining they can trade anything to salvage the flight of the 2 astronauts, regardless of the delay of the Crew 9 and its potential impact on ISS operations. As for SpaceX, the company also has to adjust its upcoming schedules to align with these unexpected changes from the government agency. This causes some delays for the company, as launch contracts and schedules are typically planned well in advance. From this, we can see the limitations of space missions or work that involves government collaboration. That's precisely why the private sector market is booming these days, and right now in a good position to continue making major contributions to the space industry. Polaris Dawn mission, set to take place at the end of this month, is a standout example of entirely private collaboration. Although Starliner's issues have caused Crew 9 schedule to get delayed, Polaris Dawn has only been slightly affected, with a minimal shift about half a month from its original mid-August target for this groundbreaking mission. But regardless of the timing, the mission's highly anticipated and incredibly important, not just for SpaceX and its sponsor Isaacman, but also for expanding humanity's footprint in space. Indeed, the Polaris Dawn mission is set to embark on a unique orbital path, beginning with an initial launch into elliptical orbit ranging from 190 to 1,200 kilometers above Earth. This trajectory is just the starting point, as the mission will perform orbital maneuvers to gradually hit an altitude of 1,400 kilometers. This will mark the furthest distance that humans have traveled from the Earth since Apollo 17 missions back in 1972. This ambitious mission will be a record-breaking milestone in terms of distance. By venturing to this higher altitude, Polaris Dawn will expose its crew and spacecraft to a stronger radiation environment, providing valuable data on radiation exposure, and that's crucial for future deep space missions. Moreover, the mission will be pioneering the use of SpaceX's Starlink satellite network for in-space communication. The crew will rely on this advanced system for seamless communication between the spacecraft and ground control, utilizing Starlink's laser communication technology to maintain a reliable link. This will be a critical test of Starlink's capabilities in supporting long-duration missions and high-altitude operations, potentially laying the groundwork for future commercial and exploratory missions beyond Earth's orbit. To accomplish this mission, a specially designed spacesuit is indispensable. Therefore, with Polaris Dawn mission, SpaceX will feature the debut of new EVA, or extravehicular activity suits, and these are designed specifically for spacewalks in the challenging environment of LEO. These suits represent a significant evolution from the intravehicular activity IVA suits that are typically worn by astronauts inside the spacecraft, that are primarily designed for comfort and protection in case of cabin depressurization. Unlike IVA suits, EVA suits need to endure the harsh conditions of outer space, providing life support, thermal regulation, and protection from micrometeoroids and radiation. SpaceX's EVA suits are equipped with advanced mobility features, allowing astronauts to move more freely while working outside the spacecraft. These suits also feature a robust life support system, including oxygen supply and carbon dioxide removal to sustain astronauts during prolonged spacewalks. One of the primary technical challenges in designing these EVA suits was ensuring they could withstand the vacuum of space while still being lightweight and flexible enough for astronauts to perform intricate tasks. Innovations include improved materials for thermal insulation, enhanced helmet visor technology for better visibility, and gloves that allow for fine dexterity. During the spacewalk, the process of suit pressurization and depressurization will be carefully managed to ensure astronaut safety. The crew will first transition from the spacecraft's cabin to an airlock where they will don the EVA suits. The suits will then be pressurized to create a safe environment for the astronauts. After conducting the necessary checks, the airlock will be depressurized, allowing the astronauts to exit into space. Upon completion of the spacewalk, the reverse process will be carried out, gradually repressurizing the airlock and transitioning the crew back into the cabin. Another important component of the EVA suit is the helmet and visor, which have been newly designed with advanced features to ensure the safety and efficiency of astronauts both inside the spacecraft and during spacewalks. The visor is a critical component, offering a combination of protection and visibility. It's constructed from specially coated materials that shield the astronaut's eyes from the intense sunlight and harmful radiation encountered in space, while still providing a clear, unobstructed view of the surroundings. This protective layer also helps prevent the visor from fogging up, which is crucial for maintaining visibility during complex tasks. The visor's functionality is adaptable to different environments. Inside the capsule, it can be adjusted to reduce glare from the onboard lighting and electronic displays, ensuring that the astronauts can clearly see their instruments and surroundings. When outside the vacuum space, the visor automatically adjusts to the extreme brightness of direct sunlight and the darkness of the shadowed side of Earth, helping astronauts maintain visibility regardless of the lighting conditions. The helmet itself is equipped with a range of capabilities designed to enhance astronaut performance and safeties. One of the standout features is the heads-up display, which provides vital information directly onto the visor. This allows astronauts to monitor their suit status, get mission updates, and even view navigational aids without having to look down at a handheld device or screen. This hands-free access to data is especially valuable during spacewalks, where the astronauts need to keep their hands free to perform tasks. On top of that, the helmet includes communication systems that enable clear audio contact with the spacecraft and mission control, as well as integrated environmental controls to regulate temperature and air circulation within the suit. These combined features make the helmet and visor a truly remarkable component of the EVA suit. All these elements have been meticulously prepared by SpaceX for the upcoming spacewalk. The new suit design was unveiled on SpaceX's website and social media channels about 2 months ago, demonstrating the company's thorough preparation for the mission and its related components. Let's wait for the mission. We're sure to get an up-close look at what marks a significant milestone for the entire space industry. Awesome. However, some may argue that this is not truly a record, noting NASA astronauts regularly conduct spacewalks, so this accomplishment may not be seen as exceptionally unique. In fact, for astronauts from NASA and other space agencies at the ISS, spacewalks are a critical part of the job while spending time up there in orbit. And since well-trained pros have been walking in space since the 60s, casual space industry observers can easily shrug off a spacewalk as a run-of-the-mill event, like the window washers dangling from a Manhattan skyscraper or a roofer in a safety harness repairing the shingles on a house. Although a spacewalk may seem like a graceful and silent ballet, there are undeniable risks when venturing into the vacuum of space, while protected from temperature swings from 250 and minus 250 degrees Fahrenheit by a little more than a tether and really expensive clothing. Walking in space is one of the most dangerous things astronauts have to do, but oftentimes it is necessary. We wouldn't have built the space station without doing spacewalks, former astronaut James Voss told me. And during his career, Voss logged 22 and a half hours in total during spacewalks and set the record with his colleague Susan Helms for the longest ever spacewalk in March 2001. Voss was so focused on his task that he didn't realize he'd been out there for nearly 9 hours. "I had no idea," he said. Spacewalks have a remarkably safe track record despite their evident danger. Astronauts on spacewalks put on a tether suit outside the space station that feels like a retractable dog leash, said Nicole Stodd, whose 2009 spacewalk lasted a little over 6.5 hours. If the tether were to snap, astronauts have a jetpack that could glide them safely back to the space station. On Earth, astronauts trained using the jetpack in virtual reality. You don't want to use that in real life, Stott said. Astronauts extensively train in a pool at the Neural Buoyancy Laboratory in Houston to mimic the conditions of space. Unexpected problems still do crop up. For instance, there's the issue of how to make sure your power drill doesn't float away. But Polaris Dawn's soon-to-be astronauts have been traveling too. Since May 2022, the crew have undergone ample training in skydiving and diving, with the U.S. Air Force Academy, zero-gravity flight, and fighter jet piloting similar to NASA astronauts. And that's not including the training for specific jobs and experiments that each crew member will run on a mission. During a spacewalk, there are handrails and mini tethers for every tool and workstation an astronaut stops at. There's no weight in space, but the mass of the suit does drag on the body, and that slows the astronaut down. It makes their movements intentional, but still slow. Things take longer when you do it in a spacesuit, Voss said. Polaris Dawn, if successful, is a small but significant step towards Elon Musk, Jeff Bezos, and other space enthusiasts' visions of regular civilians, not just elite astronauts, one day living and working in space. Stumbling on the racetrack is something no one can avoid, but getting back up after a fall is what truly shows the mettle of a giant. Speaking of this, we must mention SpaceX, a company that stands out from the rest of the space industry when they've shown impressive resilience and growth following the failure of the second stage of the Falcon 9 rocket. Moreover, recently, what their workhorse rocket even just did in Florida shocked NASA. How did Elon react? All right, let's continue. It's been a month since the launch issue of Falcon 9, which broke its streak of 325 successful flights. SpaceX has bounced back with a series of impressive launches. Just last week, SpaceX hit several milestones. The Falcon 9 launch, August 7th, marked the company's 80th mission this year. We're just halfway through the year. Okay, maybe a little bit more, but still, even though the company's behind its target launch rate, it's halfway towards the goal of hitting 148 rocket launches. The current launch average interval for Falcon 9 is 2.82 days. If SpaceX wants to meet or come close to its target of 148, they'll need to reduce the interval to 2.47 days or even lower it to get higher efficiency. Although the repeated pauses in launches due to the second stage issue have slowed SpaceX down a bit, the company's ability to make up for lost time is clearly evident. With Falcon 9's 75th launch of the year, it's completed its 25th flight from Vandenberg Space Force Base. Compared to 2023, SpaceX launched 28 rockets from SLC-4E over the entire year. August 2nd, SpaceX launched the Starlink Group 10-6 mission from NASA's LC-39A launch pad. This was SpaceX's 50th mission from the East Coast, including both LC-39A and SLC-40, and the 15th launch from this historic pad. Everything seemed to be going smoothly, but an unexplained glitch has happened. On August 11th, the anticipation was high for the Falcon 9 to carry 23 Starlink satellites up into orbit, representing another leap forward for the rising space company founded by Elon Musk. Originally, the liftoff was set for 10:59 a.m. Eastern, and all systems seemed to go as spectators gathered to witness the launch. But as is often the case with space launches, things can change at the last minute. 46 seconds before the scheduled liftoff, the countdown suddenly stopped, sending waves of confusion through the crowd and the SpaceX team. The launch director indicated via the live stream,
"Launch abort is running,"
leaving many to wonder what had gone wrong. Following the unexpected pause, SpaceX took to social media to announce today's Falcon 9 of the Starlink was paused at T-minus 46 seconds. Vehicle and payload are in good health, and teams are resettling for a launch attempt on Monday, August 12th. However, this news doesn't completely dampen the excitement. Instead, it's just another thing on a long list of factors that space enthusiasts have to face while waiting for rocket launch events. With launches often getting scrubbed to weather, technical issues, or routine checks, enthusiasts quickly shift their focus to the next launch opportunity. Observers are reminded of how patience and adaptability have become deeply ingrained in those involved in space exploration. SpaceX's proactive approach and regular updates have helped maintain public interest and engagement. The countdown to the next launch attempt is set for 6:37 a.m. August 12th, with backup windows extending throughout the day. The transparency here is something we all need to appreciate, as SpaceX consistently keeps us all informed and ready to deliver moments of excitement, even if there is sometimes cause for impatience, especially compared to companies like Boeing or even NASA, which tend to be more secretive about issues with Starliner. After all, the Falcon 9's adaptability and the company's tendency to overcome challenges are helping shape the future of space missions. The waiting game continues, along with the extreme excitement of anticipating what SpaceX is going to do next. And they did not disappoint. Even though SpaceX did have one mission scrubbed, on that same day, Falcon 9 set a new record. During the launch on the night of August 11th, Falcon 9 successfully deployed 2 satellites that will provide broadband coverage in the Arctic region. According to SpaceX's mission description, this marked the 22nd launch and landing of this particular booster. This tied the company's rocket reuse record, which was set last June during the SpaceX Starlink internet satellite launch. The booster, listed as B-1061, will now be brought to land, checked over, and refurbished for its 23rd flight. The booster previously launched Crew 1, Crew 2, SXM-8, CRS-23, IXPE Transporter 4-5, Globalstar FM-15, ISI Aero C-3, Korea 425, Maxar-1, and 10 Starlink missions. It's tied with B-1062, which launched and landed for the 22nd time back in June. Before Sunday's mission, B-1061's most recent flight happened on June 8th when it deployed a batch of Starlink satellites, while its first launch took place in November 2020, where it sent SpaceX's Crew 1 astronauts to the ISS in the Crew Dragon spacecraft's first operational mission. B-1061 has another claim to fame for becoming the first booster to launch all of SpaceX's different launch sites and returning to all of its operational drone ships and landing zones, except the rarely used LZ-2 at Cape Canaveral in Florida. This is SpaceX's first-stage rocket booster reuse system, which has contributed to several successful missions, including the deployment of communications satellites and resupply missions to the International Space Station. After launch, the booster is expected to land on SpaceX's drone ship stationed off the coast of Florida, a maneuver that many admire as part of the company's innovative approach to reusability. But what really draws attention to the Falcon 9 missions is their impact on technology and, more broadly, on our daily lives. Starlink satellites are paving the way for improved internet access, especially in rural and remote areas, transforming the way people communicate and access information. So far, Starlink is now available in 100 countries, Elon shared. However, in reality, as of the time we made this video, that number is even higher. The rise of Starlink as a legitimate internet service provider has been impressive. Starlink started its first public beta of this service in October 2020, less than 4 years ago. As of early March this year, it included over 6,000 mass-produced small satellites in LEO, communicating with designated ground transceivers. Nearly 12,000 satellites are planned for deployment, with the potential to expand to 34,000 later. SpaceX announced surpassing 1 million subscribers in December 2022, 2 million in September 2023, and 3 million in May of this year. While Starlink has drawn a significant amount of criticism due to a polarizing nature of Elon, the service has proven its invaluable worth globally. The system played a crucial role in the war in Ukraine, enabling Ukrainian forces to maintain communication despite Russia's efforts to cut off the country's internet. Starlink's also been used in emergency situations, like in Brazil, where it was deployed after flood damage. Moreover, the Starlink network is now being used for military applications under the name Starshield. Starshield is the militarized version of SpaceX's Starlink satellite internet services, with enhanced encryption and other security features. Unlike Starlink, that's a commercial service, Starshield satellites will be owned and controlled by the U.S. government. This development has driven competitors to frantically keep up with SpaceX's Starlink, including China. Recently, China made a significant advancement in its efforts to create a competitor to SpaceX's Starlink by launching the first of 14,000 satellites that it hopes will provide broadband internet service from space. This constellation, named Thousand Sails, hailed by domestic media as China's answer to SpaceX's Starlink, aims to join a number of large-scale space projects already planned or operational by broadband satellite internet providers in various countries. Thousand Sails is one of 3 major constellations planned by China, which could see the country's companies launch nearly 40,000 satellites into LEO, defined as no more than 1,200 miles above Earth in the coming years. The so-called mega constellation refers to a network of hundreds of thousands of satellites orbiting in space. The launch comes as China boosts its commercial space sector as part of Beijing's broader effort to solidify its position as a dominant space power. The nation's made significant strides in its ambitious national space program, with goals to send astronauts to the moon by 2030 while launching satellites linked to the military for positioning, communication, and surveillance. Experts say that controlling LEO broadband satellite constellations could benefit China by allowing its companies to provide services domestically and globally, while also bolstering Beijing's diplomatic influence, control over data flows, and national security. However, that's only one side of the story from SpaceX's perspective. We also have to consider the current reality. It's undeniable that China's projects lagged far behind the competition. Starlink's up and running in many places. I'm using it right now, actually. Besides, the Kuiper project is expected to enter beta testing later this year, collaborating with 7 countries in South America to provide service. Meanwhile, China's project is expected to be only at about 4% operational by next year. At this pace, assuming an additional 4% every 4 months, China's system reaches orbit around 2033. It might secure a market from local patriots, and anyone can force it to accept the service. But given China's notorious reputation for quality, one has to wonder how long after the satellites are launched will it take for the system to actually work. SpaceX is dominating the global space industry, but Europe hopes that a new rocket will change that. However, this dream may be difficult to achieve, and it could even get worse as billions of dollars in Europe's rocket business continue to fall into the hands of SpaceX. Why is that? So in recent years, Europe has largely relied on SpaceX to launch their satellites into space. In 2023, EU officials reached a $195 million agreement for SpaceX to launch 4 highly sensitive Galileo global positioning satellites. More recently, the Ariane 6 suffered a major blow when Europe's weather satellite operator EUMETSAT announced that it'll be using SpaceX's Falcon 9 rocket to launch its next-gen weather satellite, rather than using the Ariane 6 as they originally planned. That decision stunned European officials, with French space agency head Philippe Baptiste calling it a quite brutal change and criticizing EUMETSAT for not buying European. Italy and Spain, too, have turned to SpaceX to launch military satellites, which would likely have been handled by Arianespace if European rockets were available. You don't want to depend on anybody, and that's why all the nations that are spacefaring nations want their own access to space. Lucia Linares, director of space transportation and launch strategy at the agency European Cosmos, said. Joseph Aschbacher, ESA's Director General, lamented the situation in a series of statements last year. Last May, he wrote that Europe found itself in an acute launcher crisis with an albeit temporary gap in its own access to space and no real launcher vision beyond 2030. But from this perspective of European investors, they had no other choice because SpaceX was the most suitable partner for them at this time. To quickly end this situation and pull Europe's space industry out of the fate of having no access to space, the European Space Agency, along with Arianespace, accelerated the long-delayed Ariane 6 rocket to its first launch July 9th. Although there were some issues during the ignition process, the launch eventually proceeded successfully. However, this does not mean that the European launch markets return to the space race with the major powers of the world. Even though nearly 6 billion euros in subsidies have been pumped into the Ariane 6 program, there's little chance of it defeating SpaceX. Arianespace, the firm behind this rocket, says it'll offer prices that are competitive with SpaceX's current lineup. But unlike SpaceX's Falcon, Ariane 6 is not reusable. ESA executive Tony Tolker Nielsen said there are not enough engine launches planned to justify building a multi-use rocket. That decision attracted criticism from Elon. They need to go all in on reusability or be utterly uncompetitive, he wrote in a post on X last year. Rockets are no different from other transport technologies, he said, adding, no one's going to buy a single-use airplane. Expensive, delayed, and no longer cutting-edge tech. That description applies to Ariane 6, but also to swaths of Europe's economy, with companies giving ground on solar panels, battery cells, EVs, wind turbines, and microchips to Asian and American rivals, and that's shown by the onset of American-style tech giants. Because we hadn't developed a new launcher in decades, we lost some expertise, said Philippe Baptiste, the president of France's space agency, CNES. That's the same in many industrial fields across Europe. After all, Europe doesn't want to have to spend money on Elon's SpaceX, so their best solution is to put European satellites into orbit, but at a high cost. So, whatever happened to Europe's space program? 4 months after ESA signed the contract to develop Ariane 6, SpaceX landed its first Falcon 9 booster, initiating a cycle of recovery and reuse of rockets that proven crucial in making Falcon 9 a leader in the launch market. Ariane 6 is one of the few new large or medium rockets that does not have reusability in its roadmap, raising questions about Europe's competitiveness in commercial launch contracts. But European governments are eager for independent access to space, and Ariane 6 is poised to provide that. At one point, ESA and Arianespace, the operator of the Ariane rocket family on a commercial basis, planned for a crossover flight between Ariane 5 and Ariane 6 that was scheduled to start in 2020. Instead, delays with Ariane 6 rocket left Europe without the capability to launch their own payloads into orbit for a year. Best case scenario, assuming the test flight on Tuesday goes well, the first operational launch of Ariane 6 is scheduled for December. So the new rocket won't start clearing the backlog of European sats waiting to fly on it for quite some time. But the situation's even worse. Europe's light rocket, Vega C, failed on its second flight in 2022, necessitating a redesign of the rocket's second stage, which has grounded Vega C till the end of the year. The 4-year delay of the Ariane 6 rocket with the suspension of the Vega C rocket happened simultaneously with Europe losing access to Russian rockets. Russia's Soyuz medium-lift rocket launched 27 times from the Guyana Space Center until officials abandoned the program following the invasion of Ukraine back in 2022. Had that not happened, Soyuz rockets launching from Europe's spaceport in French Guyana might have been available as a backup option for some Ariane and Vega payloads. Ideally, Europe officials want the Ariane 6 rocket to be competitive in the commercial launch industry, as its predecessor, the Ariane 5, was in the 2000s and 2010s. But Ariane 6 is emerging in a completely different market compared to Ariane 5 in its heyday, with SpaceX as dominant and a slew of other rockets like ULA's Vulcan, New Glenn from Blue Origin, and Japan's H3, plus new challengers like Rocket Lab, Relativity Space, and Firefly Aerospace. All of these rockets, except for Ariane 6 and H3, are designed with reusability in mind. One could argue that Europe began work on the Ariane 6 at the worst possible time, when rocket reusability was still a novel idea and had not been proven by SpaceX. ESA and the Ariane group locked themselves into developing Ariane 6 just before the tide turned towards reusable rockets. ULA's Vulcan launched earlier this year. You got Rocket Lab's Neutron, Relativity's Terran R, and Firefly's medium launch vehicle. They all started development after Ariane 6. However, perhaps it's fair to probe Europe's fundamental ambitions in the rocket field. Elon, the founder and CEO of SpaceX, he built it and they set the strategy with Falcon 9. SpaceX bought into the idea that lower launch costs, achievable by reusing rocket hardware, would increase the number of customers who could afford launch services. While most of SpaceX's record number of missions, more than 120 launches over the last year, carried the company's own Starlink internet satellites, SpaceX is also conducting more missions for outside customers than ever before. With its new giant Starship, SpaceX threatens to disrupt the launch industry yet again. After all, Ariane 6 is not going to be competing to launch many of the payloads that could fly on Starship, like Starlink satellites or crewed and cargo missions to the Moon or Mars. Not only in the rocket market, but European suppliers have also lost out to SpaceX in the satellite sector, even relying on SpaceX's assistance. To compete with SpaceX's Starlink, Europe decided to build a satellite recovery, connectivity, and security infrastructure on the IRIS-2 project. IRIS-2 was first announced in November 2022, with the goal of getting a Starlink competitor up and running by 2027. EU invited bids from local companies to do the work and offered 2.4 billion euros of financing to jumpstart the project that was estimated to cost about 6 billion euros to finalize. A consortium of nearly a dozen businesses, ranging from companies Eutelsat and Airbus to telecom providers Deutsche Telekom and Orange, quickly formed to bid on the contract. The problem was that they bid as a group, meaning that there was no competition among bidders that might work to cut down the cost. 18 months later, that's still the case. In March, the European Commission delayed its award of IRIS-2. The Commission did not give a reason or say when it wants to delay the award, but late last month, Germany's Handelsblatt newspaper reported that the cost estimates for what it calls Europe's Starlink alternative project had ballooned to 12 billion euros. That's 100% over budget. You got to figure that the lack of competition, along with a tight deadline for getting the constellation built and up in the air, had something to do with it, creating a perfect seller's market for this single, albeit Hydra-headed bidder. For this reason, IRIS-2 is still incomplete and may get put up for rebid, maybe to attract more bidders and hopefully a better price. Given the current situation, even when Europe's satellite project gets completed, it's going to struggle to catch up with SpaceX's Starlink. The harsh reality is that the European Union has found another solution, relying on the help of SpaceX. The EU hopes to use Ariane's new Ariane 6 rocket to launch its new Iris 2 satellites, which have not yet been built. Caveats aside, Ariane 6 has got another problem. The hopes of building the rocket for half the cost of Ariane's older Ariane 5 model have proven over-optimistic. In the last report, each single Ariane 6 launch was estimated to cost about $115 million. By comparison, SpaceX's Falcon 9 launches are advertised at barely half that price, just $67 million. Iris 2 is said to require about 170 satellites to function. It's unknown how large these will be or how many the Ariane 6 can carry up at a time. Given that, SpaceX's Falcon 9 rocket has a payload capacity roughly equal to that of Ariane 6, so it seems likely that switching launch providers alone from Ariane to SpaceX could cut the EU launch costs in half. Granted, launch costs are only part of the equation. There's also the cost of building the Iris 2 satellites to consider. But here again, SpaceX builds satellites as well as rockets now, both Starlink satellites and military-grade Starshield satellites. Whether SpaceX's satellite prices are as cheap as its rockets isn't known, but if they are, then theoretically, at least it seems likely SpaceX could both build and launch Europe's hoped-for Starlink alternative cheaper than its European rivals could. It might even be able to build an alternative to Starlink for the original target price of €6 billion, then hand over the entire project to Europe turnkey style. Abracadabra. Europe would have its Starlink alternative built by the same company that built Starlink Classic. The real alternative to SpaceX, it turns out, would be a satellite communication system that costs more than it should and arrives years behind schedule. When it comes to doing business in space, SpaceX remains the low-cost leader. And that's it for